Hello everybody, this is Mr. Dowse. This is going to be the video on section 8.1 or chapter 8, section 1 under similar polygons. So today we're going to be talking about shapes that are similar in shape, but proportionally they're bigger or smaller than each other. So the idea is, like I have a triangle here on the left here. This shape and this shape are similar because one is a bigger version of the other, or one's a smaller version of the other. Their sides are proportionally different, and so just different size but same kind of shape. So the idea here is there are a couple properties that polygons need to have to be considered similar. Their angles, or their corresponding angles. Corresponding angles are congruent, which means equal. So, for example, this angle A and this angle D are both 40 degrees. This angle B and E are both 80 degrees. And this angle C and this angle F are 60 degrees. So since the corresponding angles are congruent, that these are so far going to be considered being similar shapes. But the sides, the corresponding sides, are proportional. So the idea is, if I look at this side of 2, if I multiply it by a number, it gets me to 4. That number is going to be called the scale factor. So there's a scale factor of 2 on all these corresponding side lengths. So if I look at 2 and I multiply 2 by 2, I get 4. This side here corresponds to this side here. So if I multiply 3 by the scale factor 2, I get 6. And then from A to C and D to F, these sides correspond to each other. So 4 times 2 gets me 8. So right now, these two triangles would be considered similar triangles because their corresponding angles are congruent and their corresponding side lengths are proportional. And there's a way to, instead of writing the word similarity, there's a symbol for similar shapes, and it's this little tilde here. So for example, I could say that triangle ABC is similar to triangle DEF. This little tilde means similar to. So similar to. And I have to put it in this order because angle A corresponds to angle D. These are both 40 degrees. So that means that A and D have to go in the same order here. And since I go with B next, B is 80 degrees, E is 80 degrees, these correspond. I have to put B second and E second. And then the last one is C. C corresponds with F. So I've got to put the C and the F in corresponding places. So this is important here. So if I didn't actually have this picture here, I would know automatically if I drew a triangle that angle A and D correspond to each other because they're in the same order. B and E correspond to each other, and C and F correspond to each other just by looking at this little similarity statement. So the order that these letters are in tell you important information. So there's another bit of information here, and I mentioned earlier scale factor. Scale factor is used in dilation. So dilation is a math term for when you're enlarging or shrinking an object. So for example, from this smaller object to the bigger object, I'm enlarging it. So the dilation is, we're enlarging it. And then if I were to go from big to small, my dilation, we're shrinking it down. And then it says scale factors are symbolized by the letter K. In our book, if you see K equals 2, that means a scale factor of 2. So just, you can shorthand for scale factor, you can just say K is 2. So I'm going to do some examples here. And so to continue with this lesson, so given the similar figures, name all pairs of corresponding sides and angles. Look at the similarity statement to help. I've already given a little clue on this one, but I'll continue working on this right now. I'm going to just look at the angles first, just because they're a little bit easier for me to look at. Since the Q comes second and E comes second, these two angles correspond to each other. So I'm going to put the angle symbol here. So angle Q is congruent to angle E. So we know that angle Q and E would be equal to each other. And then if I look next here, the P comes first, the D comes first. So angle P and angle D correspond to each other. And then angle R is third. Angle F is third. So angle R corresponds to angle F. It's pretty straightforward. If I look at the side lengths, it's similar. If I look here, Q and P come second and first. So D and E come second and first. I want to put E and D. Again, you want the letter Q and the letter E to match up because those represent the same angle. Technically, you can get away flipping it around from D to E, and you'd probably still be correct. But the idea is we want to keep these letters in order. It's just important information whenever we know that. And so, for example, we could just look at the picture here. We have QP corresponds to side ED. But again, if you just look at the similarity statement, that gives you all the information you need to know without looking at the picture. So PR corresponds to DF, and then RQ corresponds to FE. And you can look at the graph here, or again, just look at the R. R is third, F is third, so those both come first. Q is second, E is second, so those both come second. And so if I were to continue doing this, if I look at number 1 here, you know what? I'm not even going to look at this picture right now. I don't even need the picture. You're welcome to look at it, but the idea is the similarity statement will give you all the information you need to know. So if I look at LM, L comes first, M comes second. What else comes first and second? The R and the S. And MN, side MN would correspond to the second and third letter, so that would be S and T. And then NL corresponds to 3 and 1, so that would be T and R. And so those side lengths correspond to each other. And then if I look at angle L corresponds to R. Angle M corresponds to S. And angle N corresponds to angle T. So that's just something information. Now, if you didn't have this similarity statement up here, you could try figuring out using something other than that. So let's say I knew only that angle L corresponded to angle R, so we know angle L corresponds with angle R. I knew that angle M and angle S correspond to each other, so I'm putting 2 tick marks to indicate that these angles are congruent. And then on N and T, I'm going to indicate that angle T are congruent because I'm going to mark those with 3 tick marks. So if you were given, let's say, the angles here, but you weren't given the similarity statement, you could still figure this information out if you look at the angles. If I look at angle L, the side opposite of angle L, and I look at the side opposite of angle R, these 2 sides have to correspond to each other because they're opposite the same angle. So if I have MN here, I need to have an S and a T, so MN, I have an S and a T. If I were to look at side S and side M, they're both opposite the side with 2 tick marks. So I know opposite of this M, we have an LN. Opposite of the S, we have an RT. So we have an RT and an LN. So LN and RT, we know that those correspond to each other. So there's all kinds of information we can use to help figure things out. So if I were to continue looking at number 2 here, we have ABCD is similar to shape HGFE. And so let's just look at this. This one might not be so obvious because things are kind of turned around a little bit. So AB, 1, 2, 3, 4. I'm just going to do 1, 2, 3, 4. AB would correspond to HG. BC would correspond to GF. CD would correspond to FE, and DA would correspond to the 4th and the 1st, so E and H. So those correspond to each other. And if I look at angle A corresponds to angle H. Angle B corresponds to angle G. Angle C corresponds to angle F. So C, we're going to have 3 arcs there, and F, we're going to have 3 arcs. And then angle D and E correspond to each other, so angle D and angle E. So there's important information that's useful. This is used in all kinds of situations. If you can understand this, it'll just really simplify how to solve for various situations. So if I look at the second example here, complete the similarity statement for the similar figures and then find the scale factor. So complete the similarity statement. So if we look here, angle L is opposite the largest side. Angle R is opposite the largest side. So I know L and R have to correspond with each other. And then if I look, we have the smallest side is opposite of M. The smallest side is opposite of S. So I could go with M and S. So M and S would go with each other. And then that just leaves K is opposite the middle side length. Q is opposite the middle side length. So that means K and Q would have to correspond to each other. So again, if you look at the angles and the sides opposite those angles, you can use relationships like that to help you understand what letters go with which other letter. So if I look here in number 3, CBAD. So this is a little interesting. So CBAD. So C is here. This looks to me like a parallelogram. It is, because opposite sides are equal to each other. So I'm just going to look here and just say that Y corresponds to C. I can get away with another organization way of doing this, but since these are essentially, they're the same shape and these opposite angles are equal to each other, you can come up with a different couple sets of different answers here. But I'm going to say for now C and Y correspond with each other. I'm just going to move clockwise now around the shape. So that means that B and X correspond to each other. And I'm just going to keep going this way. So A and W would correspond with each other. And then A and D would correspond with W and Z. So this is one of the similarity statements. I could have also chosen W to go with C because these angles are going to be identical. This is a parallelogram, so opposite angles are equal. So I could have also have done like W, Z, Y, and X as well, and I would have been correct as well. So if I look at this next one here, 4, again, I'm just going to pick, since these are both rectangles, I'm just going to say that these sides that are in the same spot are congruent to each other. So if I have S and J, J and S are going to go with each other. So J is going to be the second term. The R, so we're going counterclockwise. So S and R, so R and H are going to go with each other. So H, I'm going to put that with the R. Since R is first, H is first. And then it goes to P. Oops, they're now going up here. So if I go up here, we have a P and we have an F. And then I can have a Q and a G. So a Q and a G. And that would be the right similarity statement. So moving on here, we also need to find the scale factor between all these shapes. Scale factor is very tricky. This is incredibly important to understand. I always look at shapes going from left to right. And going from left to right, we need to think, relatively speaking here, what does the scale factor actually need to be? So if I'm looking from left to right, to find scale factor, you find corresponding side lengths that are equal to each other proportionally. So these two sides are proportional to each other. They're similar sides, just one's bigger or smaller than the other. So whenever you're dealing with scale factor, if the scale factor is greater than 1, that means you're enlarging from left to right. If your scale factor is less than 1, that means you're shrinking from left to right. So if I'm looking at 12 and 8, I'm going to make this a fraction, or 8 over 12. These are both correct depending on how you look at the shapes. Since I'm going, though, from a bigger shape to a smaller shape, my scale factor needs to be less than 1. And if I look at this guy is greater than 1, this guy is less than 1, so this is going to be my scale factor, 8 over 12. But I need to reduce my scale factor down as much as I can. And these are both divisible by 4, or you can type in your calculator 8 over 4. Oops. Sorry, 8 over 12 is what I meant to say. And you can hit math, enter, enter, and it will reduce the fraction down to 2/3. So the scale factor here, K, is actually 2/3 in this problem. So if I multiply 12 times 2/3, it would get me 8. If I multiplied 9 by 2/3, that would get me 6. If I multiplied 6 by 2/3, that would get me 4. And so since these sides are all proportional, these shapes are similar. So we can do the same thing over here for from these two shapes, but notice we're getting bigger here. We're going from smaller side to a bigger side. So my scale factor needs to be a fraction greater than 1. So if I look at 6 and 8, and I make these both fractions, only one of these is getting bigger. One of these is greater than 1. This guy reduces down to 3/4, which is less than 1, so this isn't it. This reduces down to 4 over 3, which is greater than 1. So since this is getting bigger from left to right, my scale factor is actually 4/3. Looking at number 4, same idea. I'm just going to pick 4 and 10 because these sides correspond to each other on here. This is getting bigger, so my scale factor has to be greater than 1. So if I look at 4 over 10 or 10 over 4, only one of these is a fraction greater than 1. This reduces down to 2/5, which is 0.4. This reduces down to 5/2, which if you plug in your calculator is 2.5. So this 5 over 2 is your scale factor. So that's your answer. So moving on, next example here. The two polygons are similar, write a proportion and solve for x. So I'm going to look here. Opposite the x is one tick mark, or sorry, one arc. Opposite this one arc is a 5. So these two sides correspond to each other. And then if I look at opposite the 3 arcs, I have a 4. Opposite the 3 arcs is a 2. So these two sides correspond to each other. And then opposite the 2 arcs is a 2. I'll put triangles here. Opposite the 2 arcs here is a 1. So those sides correspond with each other. Whenever we're setting up a proportion, we're going to have like a fraction equals a fraction. And we're going to put one set of corresponding sides here and another set of corresponding sides here, and then we're going to end up cross multiplying. I need to have an x in here, so I need to put my x and 5 on one side of this fraction. So since we're solving for x, I'm just going to put it on top. So one set of corresponding sides is x and 5. I could choose the 1 over 2 here, or I could put the 2 over 4 here. You'd still get the same answer. It doesn't matter. So when I cross multiply, I do x times 2, which is 2x. 5 times 1 is 5. My goal is to get x by itself, and right now my x value is 5 over 2. So that is x. Same thing over here. Look at 28. 28 and x correspond to each other because they're both opposite the one arc. 3 arcs here, we have 5 and 20. Opposite the 2 arcs is 24 and 6. And so we know which sides correspond to each other here. Again, since I'm solving for x, I'm going to do x over 28 because x and 28 correspond with each other. And then I'm going to choose 6 over 24 since 6 and 24 correspond with each other. Now keep in mind here, I forgot to mention, on the previous problem, everything on the top fraction here needs to come from the same shape, and everything on the bottom fraction needs to come from the same shape. So 5 and 2 come from this shape on the left, the x and the 1 come from this shape on the right. So if I look over here, my x and 6, since they're in the same shape, have to be across from each other in this fraction. And then I have this 28 and 24, they're on the bottom here. So if I cross multiply, I get 24x equals 6 times 28. I do not know what that is. So what is 6 times 28? That gets me 168. So we have 24x equals 168. And if I divide both sides by 24, so whatever 168 is divided by 24 will give me my x value. So 168 divided by 24 gets me 7. So my missing side length here is 7. Moving on to 6, you do something very similar here, but again it's pretty obvious. There's only a couple sides here. So when I set up my proportion, my x and 3 are going to be above and below each other. But across from this x has to be a number from the same shape, so that's 6, and 6 corresponds to 4, so this is my proportion. Sorry, I was off a little bit there. So when I cross multiply, I get 4x equals 18, so 3 times 6 is 18, and then I divide both of these by 4, and x is 4.5. So this is 4.5. All right, going to keep moving on here. So determine if the following shapes are similar. If so, find the scale factor and write the similarity. Looking at example 4, determine if the following shapes are similar. They're not giving me any angles, so I can't look at corresponding angles. But I can kind of look at the shapes and see which ones look like they're equal to each other. So it looks like S and Y are congruent. Looks like T and Z are congruent. And it looks like R and X are congruent. So from there, I can figure out which sides here relate to each other. So these are both opposite the 1 arc, opposite the 3 arc, opposite the 2 arcs, opposite the 2 arcs. So I can quickly tell which sides are similar to each other, but just by doing that same trick I did, by looking at what angles look like they're equal to each other and then looking at the opposite side. So to find if they're proportional to each other, we need to set up a ratio with all of the sides. And since I have 3 sets of sides, I'm actually going to have 3 sets of these little fractions here. So let's start with a 30. If I put 30 on top, the corresponding side 18 is going to go on the bottom. If I look at 25 to go on top, I'm going to have 15 to go underneath it because these sides correspond. And then if I have 20 on top, I'm going to have 12 go on the bottom. And notice all of these are coming from the same shape. And then all of these are coming from the same shape. So that's important that you set this up. And if I reduce these fractions down, if they all equal each other, we know that since all the sides are proportional to each other, we can assume that these shapes are similar. So if I do 30 divided by 18, I hit math, enter, enter. I get 5 over 3. So that reduces down to 5 over 3. If I do 25 divided by 15, I get, oops, I'm going to hit math, enter. I get 5 over 3 as well. And if I look at 20 divided by 12 and hit math, enter, I get 5 over 3. And so since these are all have the same ratio of size, if I compare them, then I can assume that these are similar. So these are similar. So yes, these are similar. But now I need to find the scale factor. We actually kind of found the scale factor here. But remember, when we do scale factor, we're looking from left to right. So if I'm going from a bigger shape to a smaller shape, my scale factor has to be less than 1. 5/3 is greater than 1, so I actually need to flip the fraction. So if I do 3 divided by 5, that is a number less than 1. So my scale factor is 3 over 5. So by setting up the proportion, we can actually find the scale factor at the same time. So if so, let's do number 7 real fast. So just by looking at the shapes here, you can see that this guy and this guy relate to each other. This side and this side relate to each other. And this side and this side relate to each other. So if I'm going to set this up, I'm going to do 4.5 over 6, 6 over 8, and 6.75 over 9. So the same thing I want to do is I want to reduce all these down. And if you do reduce all these down, these all end up being 3/4. So you can say, yes, these are similar. And notice, though, that this is going from a smaller shape to a bigger shape. So my scale factor has to be greater than 1, and 3/4 is less than 1. So I need to flip the fraction, and the scale factor is actually going to be 4/3. If I multiply 6 by 4/3, that would get me 8. If I multiplied 6 by 3/4, it would get me a number smaller than 6. So I know that would be wrong. So you can always check your answer by just plugging in what you think the scale factor is on the numbers on the left. And if it gets me that number on the right, then you know you have it right. Otherwise, you need to flip the fraction, and that will get you the right answer. Example 5, solve for x. Assume the shapes are similar. So we need to solve for x. I'm just going to do these really fast. These are very similar to example 4. I'm just going to pick x and 3 because those sides look like they're similar. I think that's the whole point here. And then I'm just going to pick, let's say, 10 and 40. I can pick any other side I want to here, but I'm going to do x over 3 for sure, and then I can pick any other combination of similar sides if I wanted to. But I'm going to choose 10 and 40 just because I just did. I didn't really have a reason why I did that. But remember, the numbers opposite of next to each other have to come from the same shape, so x and 40 are going to go together, and then I would have 3 and 10 go together. But again, I could have put 56 here and 14, or I could have put, again, 56 or 14 here. You'd still get the same answer. So when I cross multiply, I get 10x, and then 3 times 40 is 120. If I divide both of these by 10, I have x as 12. So my value for x is 12. Same thing over here. They're kind of nice, though. They kind of gave me what the numbers are going to be here because we have only a couple options here. So we have x and 8 go together, and 4 and 16 go together. So when I set up the fraction here, I'm going to put x first. X and 8 go together, so those need to go above and below. X and 4 are in the same shape, so they have to go opposite of each other. And then 4 and 16 correspond, so that's where the 16 is going to go. And when I cross multiply, I get 16x equals 32. And then when I divide both by 16, x is equal to 2. So if I plug a 2 in here, 2 times 4 gets me 8. 4 times 4 gets me 16, so we know this is good. Moving on, example 6. A giraffe is 18 feet tall and casts a shadow of 12 feet. Corey casts a shadow of 4 feet. How tall is Corey? So notice Corey's misspelled here, so be careful. So basically what we have is we have two shapes. We've got a giraffe and we have a person. I'm really bad at drawing giraffes. I'm just going to draw more of a stick figure. This is going to be horrible. Oh my goodness gracious. So I'm just going to call this guy my giraffe. Craziness. And then I'm going to draw a stick figure for Corey. So this is going to be Corey. And the idea is that they cast a shadow. So if they cast a shadow, so the giraffe is 18 feet tall and cast a shadow that's 12 feet. So I'm going to draw a line on the ground here to indicate we have a shadow. Corey casts a shadow that's 4 feet long and we don't know what the height of Corey is. In a sense here, I could have just drawn a big triangle representing the draft's height and the draft shadow, and I could do this small triangle here representing we have a shadow of 4 and we don't know what Corey's height is. So we can make a real-world problem, giraffe and a person. We can just draw them into triangles and we can do similar figures here. So it's very similar to what we just did. We're going to have a fraction here. I'm going to put x on top. X corresponds to 18, so that's going to go above and below. And then 4 corresponds to 12. 4 and x are in the same shape, so they go across from each other. 12 and 4 relate to each other, they correspond to each other, so those go above and below. So when I cross multiply, I get 12x equals 18 times 4. And 18 times 4 is 72. And when I divide both by 12, x is 6. Yeah, 6. So we have 6 here. And again, a real quick way of checking this out is let's find a real quick way of relating these two. If I take 18 and divide by 3, I get 6. 12 divided by 3, I get 4, so I know 6 has to be correct. I know these are getting really long, and I apologize, but this is just a lot of information we're going to go over today. Last part of the notes here is over perimeter and area of similar polygons. So the concept here is, we can use proportions and similar figures on the perimeter and area of shapes. And so we're going to do a couple examples here, but there's a couple key concepts. So the ratio of the perimeter, or of perimeters, can't spell perimeter, is equal to the ratio of the side lengths of corresponding sides. So the idea here is, if I look at this example 7, find the ratio of the perimeters, well, we know the perimeter here is going to be, I'll put perimeter 2 and I'll put perimeter 1. We can find the perimeter because we know if we just add up all the sides on a shape, that'll give us the perimeter. So the perimeter is going to be 14 plus 8 plus 14 plus 8. And if you do that quickly, you get 44. And so we know the perimeter of the first shape here. So P2 is going to be 44. I don't know what P1 is, but we do know side lengths here. So I have an 8 and a 12. These sides correspond to each other. We can actually use the side lengths here to help us find the other perimeter. So the ratio of the perimeter, so let's put P1 over P2, is equal to the ratio of the side lengths, or the corresponding side lengths. So since P1 is on the big shape, I'm going to put 12 across from it. And P2 and 8 go together. They need to be across from each other. And so this is kind of the idea here. But we know what P2 is. P2 is 44. So, and I'm going to call P1 my x. That's what I don't know. So I'm comparing the perimeter of the big shape over the perimeter of the small shape over the side length of the big shape over the side length of the small shape. And if I cross multiply, you get 8x equals 12 times 44. And I can't do that in my head real fast. So 12 times 44 is 528. And if I divide both by 8, x equals, what is 528 divided by 8, gives me 66. So this perimeter of the second shape would have been 66 feet, inches, whatever that is. Now when we move on to the area, it's not quite as easy. It's the ratio of the areas, and I'll put perimeters on top, is the ratio of the corresponding side lengths squared. So there's a square here. So that's tricky. So the idea here is area of the first shape over the area of the second shape is going to be equal to the square of the side length of the first one over the square of the side length of the second shape. So we'll call this guy A2 over here. Don't know what that is. So if I have the area of the first one, so we're going to make that 27, and I don't know the area of the second shape, I'll make that x. It's equal to the corresponding side lengths of each side squared. So 27 and 3 are in the same shape, so they go across from each other. 6 and A2 are in the same shape, so they're across from each other. So if I do the math here, this actually becomes 27 over x equals 9 over 36. And if we cross multiply, we get what 9x equals 27 times 36. Gets me 972. And if I divide both of these by 9, we're going to get the area of the second shape. So 972 divided by 9 gets me 108. So my area over here is actually 108. Pretty crazy, right? So notice here the scale factor here is 2. We're doubling everything. So if the scale factor is 2 here, I take the scale factor and I square it here, which gets me 4. And if I do 27 times 4, that gets me 28. So that's kind of what we did in this situation here, but the math isn't very obvious. The idea here is if the scale factor is 2, you square that scale factor to get what the actual scale factor is going to be on the area. That's an alternative approach to solving this. So the last example here is example 9. Two polygons are similar. The perimeter of the smaller polygon is 48 centimeters. The ratio of the corresponding side lengths is 2 over 3. Find the perimeter of the other polygon. So we've got two shapes here. I don't know what they are, but the smaller one they're saying is 48. And the bigger one, we don't know what it is. So we need to put P1 here, we'll put P2 here, and I don't know what that is. I'll just make that X. But we know the corresponding side lengths, basically the scale factor here is 2/3. So I could put like a 2 here and a 3 here to indicate that these guys have a ratio of 2/3. So if I want to find P2, we just do P1 over P2 equals the corresponding side lengths. So P1 is going to be actually 48. So let's just do this. 48 over X, I don't know what that is. And then the corresponding side with 48 is 2. The corresponding side length of P2 is 3. And if I cross multiply these, that'll get us my answer. So whatever 3 times 48 is, that gets me 144. And if I divide both of these by 2, X is 72. So another approach here, so this is 72. Another approach here is, since you know the perimeter is getting bigger from left to right, my scale factor has to be greater than 1. So if my scale factor here is greater than 1, I just need to flip this to get 3 over 2. And so I can also do 48 times 3 over 2, and that would also get you 72 here. So you just take the scale factor from smaller to bigger, and you multiply that by the perimeter, and that will also get you your answer as well, which is what I got. I know these are very long, and I apologize, but this is just a lot of information to go over in one day. If you have any questions, please come to tutoring, and that's it. Bye-bye.